Hi, this is your lesson 5-4, solving compound inequalities. So let's start off with some definitions. Let's review your old vocabulary first. This is what an inequality looks like. You have x is greater than 3 and x is less than 7. These are two different examples of inequalities, and we can also graph the inequality. This is what x is greater than 3 looks like. We notice that it can be equal to 3, so that's why it's closed here, and it goes all the way to the right because that is where x is greater than or equal to 3. Next, it's x is less than 7. It is open here at 7 because it does not include 7. And x is less than 7, so it's all the values to the left, 6, 5, 4, 3s, and so forth. So, what is a compound inequality? A compound inequality is a combination of two inequality statements. The best example I can give you is like at McDonald's, where it's like a combo meal, okay, where you can choose one sandwich, two sides, and one drink, right? It's a combination of things. So the compound inequality is going to be a combination of inequalities. So this is the first type of compound inequality, the intersection. We call the intersection of two inequalities is where the graph of the two inequalities overlapped. So we have x is greater than 3, which is our previous example, and x is less than 7. So if we found the intersection between those two inequalities, we would say x is greater than 3 and x is less than 7. So notice how I just get this graph, which is x is greater than or equal to 3, and x is less than 7, and you put them together. The place that they intersect, right? Do you see how it's closed on 3 here, and it is open on 7, and it only highlights in the between? This in between is referred to as this, where x is less than 7. Do you see how x is less than 7? So 6, 5, 4, but x is still greater than or equal to 3. That's why it stops here. Close dot here at 3. So this statement is the intersection of these two inequalities. A key thing to remember about the intersection of the two inequalities is that it uses the word and. When you see the word and, it refers to the intersection of two inequalities. You can also see it in this form as well. For those who want to do higher level mathematics, I would like to give you a formal definition of the intersection. This the idea of intersection in the sense of inequalities, it comes from a branch of mathematics called set theory. Okay, so where you're going to see it in high school is you're probably going to see it when you take AP Stats, when you deal with probability, but in college you're going to see it when you do like group theory and set theory. Okay, um, so right here, the mathematical definition. The intersection of two sets of A and B is the set of elements that are in both A and in B. So the best way to visualize this is by the Venn diagram. Do you see the set of A and do you see the set of B? The intersection here is the purple spot, okay, or the blue, right? We call that the intersection between A and B. The symbol is an upside down U, okay? And that is the symbol of intersection. This is the formal definition because remember inequalities, the solution for inequalities is represented by a set or a list of numbers. So when we say the intersection of two inequalities is basically referred to this, is the intersection of two sets. Alright, let's look at some examples. You have example 1, solve and graph an intersection. We know that this is an intersection because it is in this compact form here. Then they asked us to solve that compound inequality, then graph the solution set. Here is the solution. First, express -2 is less than or equal to x minus 3, which is less than 4. okay? Using and because it's intersection. Then solve each inequality. So here you go. I'm not going to show the work step by step because I'm going to assume you already know it from the previous lessons. Here's the inequality. You add 3 to both sides, then you simplify. So here we got x is greater than or equal to 1. Then the second inequality, all right, x minus 3 is less than 4. Okay, you have to add 3 to both sides and simplify. So it becomes x is less than 7. So do you see how you have two different answers? It is because these are two different inequalities. Okay, you have this inequality and you have this inequality. That is why there are two solutions. Okay. Here you go. Here's the first one. Here's the second one. And remember, it's the intersection, so we use the word and. So we would say the solution set is this. It's this solution set with this solution set. They're together. It's the and statement. So x exists less than 7, but greater than or equal to 1. Do you see how this solution set is a combination of the solutions from the left-hand side and the right-hand side of the two inequalities? Here's the graph for x is greater than 1. Do you see how it's closed here? And x is greater than 1, so it goes all the way to the right. Then you have the graph of x is less than 7, which is open on 7, and it goes all the way to the left because x is less than 7. The intersection is when it's the where they overlap. So here is where they overlap. It's open on 7, close on 1. You see, open on 7, close on 1, and it's the solution or the elements that exists between open of 7 and close of 1. Okay, so that is the intersection. A neater way to do the problem is to actually keep it in the compact form. Do you see how this problem I made it into two inequalities and solve it? This is a neater way, is in the compact form. Okay, so here's the solution. Write the original compound inequality. Add 3 to each expression because you're trying to get x alone. Do you see here, even still here? You see how they still had to add 3 to both sides? Here, right? Okay. You add 3 to all the expression. They have left hand side and the right hand side, okay? So on the left hand side, after you simplified, negative 2 plus 3 is 1. On the right hand side, 4 plus 3 is 7, okay? And remember, this minus 3 is add 3 here, so that becomes the 0. So your solution would be x is less than 7, but x is less than 7, but greater than or equal to 1. So your solution set, that's the beauty of this format. It's already in its compact form. X is less than 7, but greater than or equal to 1. Okay? So that, but again, the graph is the same way. Okay? The graph is the same solution. This method just is a compact way of doing the problem. Okay? Now, what I would like you to do is the guided practice. I would like you to solve each compound inequality, then graph the solution set. Do 1A, then do 1B. Please pause the video and attempt to do the problem. Now I will be showing you the solution for it. Here's 1A. Y minus 3 is greater than or equal to negative 11, and y minus 3 is less than or equal to negative 8. You should notice something about the word and, okay? I'm going to do it in compact format because the and tells us that it is the intersection. It is a compound inequality. I can put this into its compact form because this should be an 8. Something's off. This should be an 8. Yeah, there's off here. So you can add 3 to both all three sides of the inequality. But remember, this should be a negative 8. Okay, this here should be a negative 8, right? So the left hand side, when you add 3, so it's still negative 8 is this negative 11 plus 3 is still your negative 8. On the right hand side, it should not be a 7 here. It should be a negative 8 plus 3 should be a negative 5. So here should be a negative 5, okay? This is not a 7. It should be a negative 5. So we would say x is less than or equal to x is less than or equal to negative 5 but greater than negative 8. Okay, again, this is the solution set, but this 7 should be a negative 5. Okay, again, it should not be on 7, it should be on negative 5, so it should be somewhere right here. Okay, sorry about that. 1b. Okay, it's in its compound inequality. Subtract 7 to all parts of the expression, the left hand side and the right hand side. Okay, then you can simplify. 6 minus 7 is negative 1. 10 subtract 7 is 3. Okay, plus 7 minus 7 is your 0. Okay, so it looks like this. X is less than 3 but greater than or equal to negative 1. You see, it's already neat. It's in its compact form. So your solution set will be, it's a solution set of x, and x is less than 3 but greater than or equal to negative 1. So do you see how it's open here on negative 3, close here on negative 1, because this is a less than, it's open, but this is a greater than or equal to, so it's closed. And it's the solutions that exist in between here. So 0, 1, 2, right? 1/2 would work, right? Those are all the variables that would make this solution set true. Now, there is a second type of the compound inequality. The union of two inequalities is where there is both the graph of where both the graphs of the two inequalities, okay? So here's the first one. X is greater than 2. Do you see how it's open on 2 and goes all the way to the right? And x is less than or equal to negative 1. So the union is where both of these, right? You look at that definition, where there is both the graph of the two inequalities. Do you see? The first inequality is right here and the second inequality is right here. So the union is when you have both of them right here. Okay? The key part of the union is seeing the word or. When you see the word or, that should tell you that it is a union between two inequalities. So for those who want to do higher mathematics, the union, a better definition or the more mathematical definition in higher mathematics is the union of two sets A and B is the set of elements that belong to either A or B. Okay, here's the visualization. This is A and this is B. So the union, right, the upside down U here is the symbol for the union, right? It's where both A and B exists, okay? Good? That is the union where it can be either A or B. Good? Alright, so review. Two types of compound inequalities. Your intersection, which is the inside here, and it's represented by the N, right? The upside down U. And the union, which is everything here, okay? Right? It's everything here. That is the union. This is the best visual that I can give you in terms of what the intersection is and what the union is. Example 3. Solve and graph a union. The problem is solve negative 2m plus 7 is less than or equal to 13, or 5m plus 12 is greater than 37. Then graph the solution set. Here's the solution. Think about it this way when you see the word or, because you know it's a union. Treat it as two problems, okay? Because it's or, so treat it as two problems. Don't put it into the compact form. Treat it as two different problems. Here's the problem again. Here's the solution. I write my original inequality. This is my left one, right? The negative 2m plus 7 is less than 13. Subtract 7 to both sides. Simplify, so negative 2m is left over on my left hand side, which is going to be less than 6. Divide negative 2, because I'm trying to get m alone, to both sides, and in the process of dividing by a negative value, I have to change the direction of the inequality. So m is greater than negative 3. That would be my solution to this inequality. The second inequality is 5m plus 12 is greater than 37. Okay, you have subtract 12 to both sides, then you get 5m, which is greater than 25. Divide 5 to both sides because you're trying to get m alone, then you get m is greater than 5. That is your solution to this inequality. So the first inequality, right, the minus 2m plus 7 is less than 13. The solution for this one is m is greater than negative 3. The solution for 5m plus 12 is greater than 37. The solution for that inequality is m is greater than 5. So put it into solution set format. We put m bracket bar m is greater than negative 3. The word or m is greater than 5. This is how the solution set looks like for the union statement, because remember it uses the word or. Here's the graph. This is the graph for m is greater than negative 3. Do you see how it's closed for negative 3 and it goes all the way to the right? Because those are the values where m is greater than or equal to negative 3. Then you want to graph m is greater than 5. It's open on 5 and it goes all the way to the right because those are the values that is greater than 5. If you find the union, right, you will put this and this together, okay? But notice that the graph of m is greater than negative 3, right? The solution for this already contains every point in m is greater than 5, okay? Remember, right, that it's the definition of the union is the solution set can be either, okay? So this graph would be a visualization of these two compound inequalities. For those who want to do higher level mathematics, what people say here is that the solution set of m is greater than 3, okay, the solution set of m is greater than 5 is a subset of m is greater than negative 3, okay? So you would say that this is a subset of this set, okay? But that's in case you want to do higher level mathematics. What I would like you to do is now do a guided practice for this. Solve each compound inequality, then graph the solution set. Notice that these are all ORs. 3a is an OR and 3b is an OR. That should already recognize that these are going to be unions. Okay? Please pause the video and attempt to do the problem. Let's go over the solution. You have 3a. You have two inequalities. A plus 1 is less than 4, or a minus 1 is greater than or equal to 3. Because I already know that you already know how to do inequalities, right? Single step inequalities. I'm going to show the solution in not complete detail, okay? So here is how you solve for a on the left hand side inequality, right? You just subtract 1 to both sides. On the other inequality, you add 1 to both sides. That's how you get a alone. So a is greater than 4. So your solution set is the union of these two sets, this set and this set. So you would say a is less than 3, or a is greater than 4. If you graph that, notice that a is less than 3 is open on 3 and it goes all the way to the left because those are the values that a is less than 3. Also, a is greater than or equal to 4, which is closed on 4 and goes all the way to the right. Okay, that would be the union. 3b, x is less than 9, or 2 plus 4x is less than 10. My original first inequality is x is less than or equal to 9. X is already solved for, so I don't have to do anything else here. On my right hand side, this is the original second inequality. 2 plus 4x is less than 10. Subtract 2 to both sides. 4x is less than 8. That should be an 8. That should be an 8. Okay? 4x, so you have 4x is less than 8. So 4x divided by 4, you have divide 4 to both sides. Okay, this is off because this should be an 8. Okay, this should be an 8. 10 subtract 2 is an 8. Okay, 8 divided by 4 should be 2. So the answer here should be x is less than 2. It's not 2.5 because remember this is an 8. Okay, there's an error here. All right, so we would say that so the solution would be x is less than or equal to 9, or x is less than 2, not 2.5. Remember, this is a 2 because of the error here, okay? There should be an 8. 8 divided by 4 is a 2. So the graph, right, should be right here. X is less than 9. So do you see how x is closed on 9 and goes all the way to the left? And x is less than 2 already exists in here. So x is less than 2 is a subset of this inequality. That's why you only have this, because this solution, x is less than 2, exists inside of this inequality, okay? This is why the graph looks like that, okay? There you go.